Hello, welcome back to Cracking the Cryptic, and Biscuit has sent us a puzzle that they fear might be a little too easy, but they noted that we often like to have a mix of difficulties and that we sometimes ask for easier puzzles, and it's a good idea to send it. The testers have let this one through, so it's certainly, we do like a good mix of difficulties. As long as a puzzle has something interesting about it, that's always going to be fine. So actually, it takes me back to the early days when we first started solving Sudokus. We were just thinking we were going to be demonstrating puzzles, and we weren't expecting very difficult to necessarily play a part ever. And then gradually over the years, people have sent us harder and harder puzzles to really test us, I think. And although that's fun, it is... Frankly, I prefer puzzles that I feel confident I'm going to get through because it just reassures me. Anyway, so I'm really looking forward to having a go at Treasure Map X by Biscuit, which features Dutch whispers, which will please the Dutch people watching, I'm sure. But also, don't forget that we have a number of apps which feature Line Sudoku and Domino Sudoku and Arrow Sudoku, among many others. They're all available on the links under the video, and they are brilliant handcrafted puzzles with useful hints that teach you Sudoku as you go, and we recommend them highly. Now, other links under the video include how to get to the Discord server, all our books, all of our merchandise, like this rather wonderful Cracking the Cryptic mug, Sven's Sudoku Pad, and Patreon, where you can still play the CTC Snake Egg Collection quiz, Sudoku hunt, puzzle hunt even, because it's not all completely Sudoku. Brilliant stuff by Glum Hippo, and there's loads of other stuff on Patreon. Simon solving Bug Bite, me solving difficult crosswords, and the like. But the first link in the description field is to Treasure Map by Biscuit. Yes, I mean, I sort of see rolling hills here on the treasure map and a river perhaps, and X marking the spot in the middle. That's why there's only one X. Right, what are the rules? The rules are normal Sudoku rules apply. So 1 to 9 will go in every row, every column, and every 3 by 3 box. Digits separated by the X, sum to 10. Digits separated by a V, sum to 5. All such possible XV pairs are given. So there's a big old negative constraint. That means that those two, for instance, there's no V or X between them, so they can't sum to exactly 5 or 10. And that's probably going to be important. Digits along an arrow sum to the digits in the attached circle, the digit in the attached circle. Adjacent digits on an orange line have to have a difference of at least 4. And there are 3 separate orange lines crossing each other here. So those two are on one line and those two on another. Those two are on that same last line and those two are on a different one. So each mountain is a separate thing here. I mean, that's obvious really. The line's very unlikely to curl from the corner back south, but we've stated it. Now, on the blue line, it's a region sum line. So box borders divide the line into separate regions. That's one, that's another, that's a third, that's a fourth, and that's a fifth, and they all have the same sum. Right, give it a try, as I say. It'll be good. Oh, this arrow appears above the line in on my screen. If it doesn't when you call up the puzzle, you can click on settings, and there's one called, what is it? Draw arrows above lines, halfway down the visual bit. And that needs to be set to on to have the arrow appear above the line. Okay, those are the rules. A little bit of extra tech tip. You don't get those from me very often. And now you can start. I'm going to start the puzzle. We'll see how hard it is. Let's get cracking. Okay, so we've got a pair of V's in the center, and the only digits you can put on a V are 1, 2, 3, and 4. So that is a set. That's also 1, 2, 3, or 4. I mean, we could do the same for all the V's. Never afraid to do some pencil marking, because my name is Pencil Mark. Now, these other cells in the central box are 5, 6, 7, 8, 9. Now, that's really interesting. On this orange line, there's no problem. We have a low digit here and a high one here. Same with those two. But look at these two. How are we going to get a difference of 4 there? Well, there's only one way, and that is by having a 5-9 pair, I think. So let me just clear my throat so I don't start coughing at you. That's a 5-9 pair. These other cells in the box are 6, 7 and 8 as a triple. That now can't be a 1 on the X. And that means these two can't be 4s, I suppose. Oh, this is quite a high digit to have on this arrow. So that is 7, 8 or 9. This is 1, 2 or 3. Now that works in terms of the polarity alternation, by which I mean a high digit being next to a low digit on an orange line. Right. Oh, this digit is a single cell segment of the blue line, and so are those two. So those all have to be the same. So we could write 6, 7, 8 into all of them. And I don't know what we do next. This is going to have to be low to be next to 6, 7 or 8. 4, I think, is the highest it can be. So it's another of these lows forming a triple in its row and column. That's a 1, 2, 3, 4 set in row 5. So everything else is high. Ah, that's getting interesting down this line. How... I suppose this could be a 9 and that a 5 again. Or, how could this be lower than that? It's got to be the sum of these two. I suppose it could be 3, 4 or 5 then. But then it couldn't sit next to this if it was 3 or 4. Yeah, okay, this digit can't be 1, 2, 3 or 4 because of that. So it is 5, 6, 7, 8, 9, and we've got the same trick again. This must now be a 5, 9 pair. Is that right? I just don't want to think I've missed something. I think that is right. That's a 5, 9 pair. Now, if that's a 5, oh, that's really interesting. Those two would add up to 5, but those two would add up to 5, and that can't work because that digit can only go with the one digit that takes it up to 5, either there or there, not in both places. So that must be a 9. Now, this has reminded me about the negative constraint, which I'd forgotten about. But in the meantime, we get to do that. I've just seen a very nice point that I wish I'd used. I'll just take you back to where this was a 5, 9 pair. Now, one of them has to be a 5. And on the line, that means that the 5 has to be, given that these are low, the 5, whichever one it is, has to be next to a 1. So one of these two cells had to be a 1. And that meant this couldn't be a 1. And that meant this was a 2, 3 pair, and this is the 1, 4 pair. So now I can restore 5 and 9 there. And this becomes a 1 now because of the 5. That becomes an 8 because of the 4 on the Dutch whisper line. Now, there's only one way to make up the treasure map X, and we've found our treasure already. That's a 3 and a 7. That must be right, I think. Those two are both 2s, and that's a 6, and we've done the central box. So we went straight to the center of the treasure island and identified the treasure. 2, 3 pair there, that's a 1. That works on the whisper. Now on the blue line, this is a 6, and that, what happened there? This digit is a 6, and that's a 5. These greens are 7s now. That's why we coloured them green. Let's get rid of the green. It's done the job. This sees 7 and 9. Oh, and it also adds those two cells. So every which way, that's an 8. We can place 8 in box 6, and then 4 and 7, and we've got an arrow, and we're just flying now. So it is quite a manageable puzzle. 1, 2, 3, and I did want a low digit there because of those. In fact, we can take out 9 and 5. This is a 6, 7, 8 set. This is 4, 5, 9. We're not allowed 4 on the orange line. The negative constraint, which I've barely used yet, must be coming into place soon. I don't know that it's helping any of these. Probably is, but I can't see it. Okay, so we go somewhere else. So there isn't many other markings on the grid. This seems to be able to be 9, 1, 3, or 4. And that might even not be an exhaustive list, so I'm not going to pencil mark that. This circle is adding 5 plus 1, 3, or 4 there to get to 6, 8, or 9. That's a bit of a dead stop, actually. We've got a 4 here, so those can't be a 4, which means those can't be a 1. And we've got a 3 in this column. So we take 3 out of there. Those are a pair of evens, so these are a pair of odds now. And that's a 2, 4 pair. In this column, we have 1, 5, 7 to place. Bottom one can't be a 7. In this column, 2, 6, 9, I think. And here's the negative constraint. 4 and 1 would have to have a V between these two cells. So that's a 3, that's great. That's a 2, that's a 4, that's a 1, that's a 5. This one is, well, it's not allowed to be a 9 by the negative constraint, so it's 2 or 6. Up here we have a 1, 7 pair. By Sudoku, these two aren't allowed to be a 2 because of that. So that's a 6, 9 pair. We get 2 in that corner. 3, 6, 9 here. Now what's not allowed by the negative constraint? 6 next to 4, 9 next to 1, and that's all. This becomes a 4. We've used a 3 there and a 1, 2 here. Yes. 4 and a 5, 8 pair. Are these not resolved by the negative? Don't think so. Right. 5, 5. There is a 5 in one of these two. There's a 2 in one of those two, and that's really nice. Because of those 2s, there's a 2 in one of those cells. This can't be an 8 now, because there's no X anywhere here, and if 8 was next to 2, it would need one. So that's not 3. That's 1 or 4. 9, 1 wouldn't be allowed. Seven is placed in box 8, hadn't seen that. And where's 3 in this box? It's not allowed to be next to 2 or 7 because there's no markings. So 3's in one of those cells. And that doesn't finish off anything. This is strange. I thought we were flowing along nicely, and it's ground to a bit of a halt. I'm probably missing negative constraints in all sorts of places. They must be available. Now we've got actual digits in the grid. I would have thought there are some. One of those is a 2, so they can't sit with a 3. Okay, that's very interesting. Where does 3 go in this column? Sorry, in column 6. It's a beautiful thing. It can't go here with the 2 because there would be a V. Can't go here by Sudoku. Can't go here next to a 7 or here next to a 7. So it must go at the bottom. And that does nothing else, of course. 3, 2, 7, 5, 1, 4. This is a naked single. It sees 2 and 3 in its box, 1, 4, 5, 7 in its row, 9, 8 in its column. The only digit left is a 6. That puts 9 in the circle, 4 on the arrow, 3 over here, 6 and 9 to finish the box. 4 is here in the bottom row. We've got 1, 6, 8. Right, this digit can't be 1 or 6 and sit next to a 4 because there's no V or X. And 1, 6 here are resolved by the 9 and the negative constraint. This is a 2, 8 pair. And this is a 3, 5 pair. I don't see how to resolve those. No. I don't actually, yes. This can't be a 5 anymore on the orange line. So that's a 9. And that's all it does. This is a 1, 9 pair that are resolved by Sudoku. And look at this 1, 9 X-wing. that means that 1 and 9 in the central column are up here, but they're not allowed to be next to each other. They have to be chaperoned by a 6 in the middle in this case. Because if 1 and 9 were next to each other, there'd be a kiss, an X between them. I don't mean to get too prurient and vulgar. Now, this is a naked single. It sees 2, 3, 4 in its row, 1, 6, 7, 9, 8 in its column, so that's a 5. This is a 2, 4 pair. We can resolve them with a negative constraint and the 6, which mustn't be next to the 4. And they're all doing a bit of work. 2, again, can't be next to 8. So once you get digits in the grid, the negative constraint does a ton of work. And that is quite normal. This is a 3, 7, 8 triple. So spot the pair that need to be chaperoned, 3 and 7. So that's 8 in the middle. This one can't be 3, so it's 7. That's 3. That's odd that these don't get resolved. Maybe I'm missing something. Yes, I am. 1 and 4 is not allowed, so that's 9 and 1. This is now a 6, 8, 9 triple. I can just write them in by Sudoku. And 8 is not allowed to be next to 2. So the only place for 2 in this column is at the top. And I think we're just going to finish off now. Look, column 2 just filled itself in. 8 and 6 there. It looks like the Dutch whisper lines all work. I'm just checking them all off now. That's a 2, 3 pair. This is a 5. That's a 3. 3 mustn't be next to 2 or there'd be an X. And that's great. Here we go. We're moving in for the kill on the treasure map. 1 and 7, 5 and 1, and X marks the spot. There we go. So that is the solution to Treasure Map by Biscuit. And it's a very nice puzzle. I admit it didn't take as long as some of the ones we do on this channel, but I found it great fun throughout. Really interesting. I know the negative constraint takes some getting used to, but it's a fun puzzle. And we, as always, thank you for spending your time with us. We are grateful for your company on the channel and hope you enjoyed that. Thank you for watching, and bye for now.